All right, so a little intro on conic sections. A conic section is formed when we take a what they define as a double napped right cone. All right, so it's a cone. It's right, so it means it's not leaning over. It's going straight up and down, and it is doubled over, kind of like an hourglass. All right, and when we take a plane and we cut into we're creating a cross section. Well, if we take that double napped cone and we cut it with a plane, we could form a circle. If we let that be perpendicular to our cone and form a circle. If we had it kind of at a diagonal, we could form an ellipse, which is kind of like an oval. Notice how it's not a perfect circle, it'd be more oval-like. We could have our plane intersect kind of the bottom of our cone, or maybe the top, to create different parabolas. And we could intersect both like this to form what we call a hyperbola. So, when we're talking about parabolas, which we do have already some understanding of, we looked at parabolas as quadratic functions. So the parabolas we look at today will not necessarily be functions. Okay, so that's going to be a little different for us. Circles, ellipse, hyperbola, not necessarily functions, certainly not for circles and ellipse. So we're not really thinking about functions here. We're thinking about these conic sections. We're thinking about creating equations and using equations that are modeling cross sections of this cone. We also could have the plane intersect the vertex of that cone. These create degenerate conics, not exactly what we're looking at today. Okay, so a lot of vocabulary for us, a lot of vocabulary. A locus is a set of all points that fulfill a geometric property. A parabola represents the locus of points in a plane that are equidistant from a fixed point called the focus and a specific line called the directrix. All right, there's a lot of information there. So here our parabola, which notice how this parabola is not a function, because typically when we think of a parabola, when we think of a quadratic function, we think of one opening up or down, and it would pass the vertical line test. It would be a function. Every input has exactly one output. Here, every input can have multiple outputs. This is a parabola, though, because the real definition of a parabola is any point on that parabola is equidistant from the focus. So like this point right here is the same distance from the focus. I'll go a different color on us. It's the same distance from the focus as it is to the directrix. And if you remember, when we find the distance from a point to a line, we're talking about that perpendicular distance. So a directrix is a line perpendicular to our axis of symmetry. And when we're looking at the vertex is the same distance from the focus as it is to the directrix. So if we have our vertex and we know we're adding 1 unit to get to the focus, we know we're going to subtract 1 unit to get to the directrix. All right. So as much as you probably want to just say, yeah, that's just a lot, and I think I'll just figure everything out without this. Understanding this picture right here of what's going on is key to understanding everything else we do when it comes to the parabolas and understanding their role in this whole conic section thing. Of course, the axis of symmetry, we know from quadratics, the axis of symmetry is that line that cuts our parabola in half, and the vertex is the intersection of the parabola and the axis of symmetry. Very important, once again, standard form for equations of parabolas. I can talk through all of this, but really, if I were you, I would jot this down. This is good notes to look back on as you get used to trying some of these problems out. Notice here, when we're looking at standard form, or you might hear it called like transformational form, when we're looking at these, if it's the x being squared, that's going to be our traditional parabola. That's going to be our what we think of when we think of quadratics. The parabola created that makes a function is if the x term is being squared. But if it's the y term being squared, it's going to behave unlike a function. It's very important for us. Notice we still have h and k, very similar to our vertex form of quadratic. H and k still provides our vertex. The h is grouped with the x, the k is grouped with the y. Our axis of symmetry is different if we're dealing with a vertically opening parabola or a horizontally opening parabola. The focus all hinges on our p-value and understanding our vertex. The directrix, of course, like I said earlier, if we know that our focus is 1 unit to the right of the vertex, we know our directrix would have to be 1 unit to the left. Okay, so all this comes together. On the next video, we'll start doing some problems.